All right, I wanted to get one more out on these rational functions because there is a lot going on with this, and I did vertical and horizontal asymptotes, but really didn't go through and going through the whole process. So I'm going to take this one through the whole process and get a good sketch of what this function looks like. And this one's starting off in expanded form. I don't know what the factors are yet. I'm going to have to figure that out, but there's some things I can tell from expanded form quickly that I'll be able to put on the graph. One is this is degree 2 and this is degree 3. The degree is bigger on the bottom. Degree of denominator is larger. That means when x gets really big, this is going to be closing in on 0. The denominator is going to be way bigger, so it's going to be closing in on 0, or that's my horizontal asymptote at y equals 0. It's going to be approaching the x-axis there as x gets far away from 0. The other thing that's easy to tell in expanded form is what happens when x equals 0. Those are the only non-zero terms. So when x equals 0, y is 3/4. That's the y-intercept. Positive 3/4. That's 1 point on the graph that's easy to tell from there. That's pretty much what you get from expanded form. We're going to look at the numerator and denominator separately and think about what's going on here as far as factors. This numerator is quadratic, so this is just kind of a normal factoring thing to find the factors of that. Notice that Descartes' rule for this tells you that it goes, well, this changes from positive to positive, so there's 2 sign changes there. So there could be 2 positive real roots or 0. But that goes along with the factoring patterns of this thing. Is in order to have a negative here and a +3, I have to have minuses on both of these. Got to be like 1 and 3 here. But that means those minuses mean I'm going to have positive real roots to this thing if it does factor, and it does on this one. If I have 2x and x, this works as. No, that's not right. 2x is on the other side. That's negative 2x and negative 3x adds up to negative 5x. Yeah, so that's the 1 and that's the 2. That's correct. And so if I can tell the factors of the numerator, then I can tell the zeros of the numerator when x equals 1, and when x equals, this equals 0 when x equals 3/2. Zeros of the numerator in a rational function become x-intercepts of the function. When the numerator is equal to 0, the function is equal to 0. So we have 1, 0 and 3/2, 0. The cool thing is not only are those x-intercepts, but also those are the only places that the graph could cross the x-axis. The only way you could have x-intercepts is if you have zeros in the numerator. So that's it. Otherwise, it doesn't cross this line. It approaches that line, but it never crosses it anywhere else. The denominator, a little bit of work to do to factor this thing. The denominator is x cubed minus 3x squared plus 4. So it's got maybe 3 different factors to it, and I'm going to have to try these things out. So in this one, I don't know what to start with. I'm going to have to do my factoring process and do a little synthetic division to try stuff out here. Possible rational zeros are plus or minus 4, plus or minus 2, plus or minus 1. Descartes' rule, again, I got 2 sign changes, so there could be 2 positive real roots. And f of minus x is negative x cubed, negative 3x squared plus 4. So it's going to be 1 sign change here. That means there's 1 negative real root. So there's at least one of these negative ones that work. Doesn't have to be rational, but that's what I'm going to try first. I'm going to try out these things, and I'm going to start with negative 1. My synthetic division deal. Notice I'm missing the x term there, so when I do the synthetic division, that's 1x cubed, negative 3x squared, 0x, and 4. I got to have that column in there for the missing x term, the 0 term that's in it, in the original. So copy this down, multiply by negative 1, and add, multiply by negative 1, and add, multiply by negative 1, and add. Sure enough, that came out to 0. Happened to be the first one I tried. Honest, I didn't peek, but Try and find one that works, and I did. This being 0 means that's -1 comma 0 is one of the zeros of the numerator. That's not really an ordered pair for the function itself. I'm sorry, this is the denominator. So this is not a 0 of the function. This is a 0 of the denominator. That makes it a vertical asymptote at x equals -1. The factor would be x plus 1. My factors so far are x plus 1, and then this would be my remaining polynomial, x squared minus 4x plus 4, which factors nicely. That's kind of an easier factoring thing, so x minus 2, x minus 2. So I have a 0 of multiplicity 2 in the denominator. That's also a vertical asymptote. But this one's got multiplicity 2. We'll see what that does on the graph when we have an asymptote with multiplicity 2. That means the sign doesn't change there. If it's positive on one side, when I get to the other side of 2, it's also going to be positive because this is squared right here. If they both change signs at the same time, the product isn't going to change signs. So we'll put that on the graph pretty soon. Let's see what else we need. So the factored form of this, putting it all together, the factored form from the top was x minus 1 and 2x minus 3, and the factored form of the bottom is x plus 1, x minus 2 squared. So we got the x-intercepts and vertical asymptotes written down. I'm just going to put this together on the graph. X-intercepts were at 1 and 3/2. Vertical asymptotes at -1 and 2 with multiplicity 2. Now let's start piecing this together on the graph then. So there's a vertical asymptote here, and the graph is broken up into 3 pieces by those 2 vertical asymptotes. We have zeros right here and right there. We have the horizontal asymptote is at this line. It's going to approach that as I get further out on the sides. It's approaching that from one side or the other. These are the only places that it crosses over. I guess see what's going on with that. The other information I had was the y-intercept was at 3/4. That's a big deal because that being up here means this has to be going up and it can't cross anywhere else. So if it's going up, it's got to be going up on this asymptote. These are both multiplicity 1, so the graph cuts through when it's multiplicity 1 and cuts through when it's multiplicity 1, just like a line going through them. So it has to stay above here. It must be following this asymptote up. Now, using the asymptote multiplicity, this one is a multiplicity 1, so it does change signs there. It must be down here on the negative side. And it has to stay down here and approach the asymptote because there's no places where it crosses. This one being multiplicity 2 means it doesn't change signs here. It's also going to be on the positive side when x is on the other side of 2, and it must stay up here, approaching the asymptote from above on this side. So that's got to be the graph of that. That's kind of the whole process in one pretty good example there.